Good morning everyone, I am Ocampo from 11 Quality and I am here today to discuss to you about a problem about related rates. So my problem is the number 16 problem. So the height of the water tank, which is in the shape of a right circular cone, is 300 centimeters. Its top rim, which is circular in form, has a radius of 120 centimeters. If it is filled with water at the rate of 50,000 cubic centimeters per minute, how fast is the water level rising when it is at depth of 150 centimeters? So in order to understand more the problem, I have an illustration here. So the water tank looks like this, a right circular cone, and with the height of 300 centimeters and a radius of 120 centimeters. It also has a depth, or the water level is at 150 centimeters, and we represent the radius of its depth, which is into r. So the given in the problem is the height of the tank is equals to 300 centimeters, the radius of the rim is 120 centimeters, and we represent the depth of the water as h, which is 150 centimeters, and the derivative of in terms of t, which is the rate of the water being filled, which is the 50,000 cubic centimeters per minute. So in order to solve the problem, we need to get the value of r and the derivative of h in terms of t. Let's first get the value of r. So we can get the value of r by representing it by equation of r over the radius of the cone, which is the 120, equals to h over the height of the cone, which is 300, and we can do cross multiply, which so it will become 300r equals to 120h. So we divide 300 both sides, eliminate 300, and it will become r. It is equals to 120h over 300. We can still simplify this. It will become 2h over 5. So our r is 2h over 5. So since the problem talks about water filling into a circular cone, so basically it involves volume. So we need to have the equation of the volume of the right circular cone in order to get the derivative of h in terms of time. So the volume of a cone is v is equals to 1/3 times the base times height. So base will represent pi r squared times height. So we just need to plot the value of r into the equation. So it will become 1/3 pi 2h over 5 square times 8 by h. So if we simplify this, it will become 1/3 pi 4h squared over 25 times h. So we can multiply h by 4h squared by 25 over 25, I mean. So it will become 1/3 pi 4h cubed over 25. After which we need to multiply the coefficients. So it will become 4 over 75 pi h cubed. So our volume is 4 over 75 pi. So the next thing we need to do is to get the value of the derivative of h in terms of time. So in order to do that, we need to get the derivative of the volume. So the derivative of the volume, which represents dv over dt, is equals to 4 over 75 pi 3h squared times the derivative of h over dt. So you can still multiply this. So it will become 12 over 75 pi h squared times the derivative of h over dt. You can still simplify this. So it will become 4 over 25 pi h squared times the derivative of h over dt. So since we already have the derivative of the volume, we can now get the value of dh over dt by plotting these values given into the equation. So this will be dv over dt. We already know that dv over dt is equals to 50,000. So it will become 50,000 is equals to 4 over 25 pi. So our h is 150. So we need to have 150 squared times the derivative of h over d. So we just need to simplify. So this will become 4 over 25 pi. The square of 150 is 22,500 dh over d. So we just need to continue simplifying. So if you multiply the coefficient, it will become 3,600 pi times the derivative of h over dt. So the next thing we need to do is to divide 3,600 pi both sides. So it will be cancelled. So our derivative of h over in terms of t is 50 over 360 pi, and we can still reduce it or simplify it to, so it will become 125 over 9 pi. So basically our derivative of h over derivative of time is 125 over 9 pi. If we plot a value of pi in here, it will become 4.42 cm. So basically our derivative of h over dt is 4.42. So with this, we can already conclude that the rate of the water level rising when it is at the depth of 150 centimeters is 4.42 cm per minute. So that's it. That's how you solve this problem. Thank you and God bless.